Okay. So basically TIs work this Casios are very similar. They do all the same things. The only problem with it with a Casio calculator or any other calculator, HP calculators are actually really good too. I had a student a few years ago who had an HP and it was really cool. They do basically the same thing, but it's just the placement of the buttons are a little different and how you get to certain things is a little different. But most people have TIs. That's the safest one to go with. So I'll just show you guys how we can how we can use that. So um, obviously here you have your numbers, your decimal if you need to do a point, and of course your operation buttons. A little note about negatives, by the way. If you want to make an answer negative, you don't press the subtraction button because the subtraction button is an operation, not a sign. So if you do like -6, I don't know, it's hold on. Like, and you press enter, there's like an error. If you want to make something negative, you press this button here, right here. This one here is the negative button. So this here is the button that you use to make a number negative. So that's very important there. And of course, you can do all the basic operations. So like if you do 8 times 6 and you press enter, now here's the cool thing. The calculator saves whatever answer you just previously got. So if you were to continue doing operations, so now if you press like -5, when you press minus, it's actually going to apply it to the previous answer. So if you do -5, see, it's going to do it to the previous. Then you add 9, and it's going to do it to the previous answer. Divide by 2, and it does it to the previous answer. So it always saves the previous answer. Now, for example, if you want to use that number somewhere else, you can actually see here. So the second button here is like the shift key on a computer, where if you press the second, all the buttons above it, above the keys, act like the buttons themselves. So for example, if you want to do like 9 times the previous answer, so you click second answer, and it's saving the previous answer, -3, and it does that, and it does the operation for you. So it's pretty cool. The answer button is really useful, like especially if you already calculate like a really big and ugly number and you don't want to have to like write it all over again, because you may want to like write the whole number on your paper, but you don't have to because the calculator is saving that number. So it's a very useful feature to have. Um, let's see what else is there. I'm trying to think what are some other good things to pay attention to. I mean, other than the operations, you could see that there are other operations here. So like E is actually over here. This is very interesting. E raised to the X is right above the ln. So if you wanted to access that, you could do second E. And if you wanted to know what the number E was, you do E raised to the 1, and that's the irrational number E, Euler's number, 2.718. So that's a nice one. And I think E is also here, like just by itself. Yeah, it's there as well. But E raised to the X is if you want to make it like exponential. Okay, and I'll show you guys that a little bit later. So another thing I like to do as well. Well, this is the exponent button, by the way. So if you do like 5 raised to the 7, that does 5 raised to the 7. See, this model, though, this is very interesting. This is like a slightly newer model. So it does things like subscripts and superscripts. The older calculators, which I can't, do I still have my old calculator? I feel like I have it somewhere on my desk, but my desk is a mess. I do have my old calculator, but I think the batteries are destroyed. Let me see. Yeah, I have to fix this. Yeah, I still have my old calculator. This is from when I was in high school. So the problem with the old calculators is it does it like as one line. So like I'll type it in the chat, how you would see it. If you did like 5 raised to the 7, the way it would show on your screen is like 5 with the caret symbol 7. So it would show like 5, the little up arrow, and then 7, like in one line. The newer calculators do like subscripts and superscripts. That's like the only pretty big difference. Now, where things start to get fun is with the graphing section. Okay. Now, there's a few things that you have to pay attention to before you start doing problems in AP Calc. Okay. First things first, you need to click the mode button. This is always the first thing you should do. You click the mode button, and basically you want to make sure that there's three main things that I would pay attention to. Honestly, all of these should be on the left. Like they should all be on their leftmost option. So like when you're doing numbers, you want them to just be normal numbers. You don't want scientific notation, for example. That's going to be confusing. When you're going to be working with angles in AP Calculus, you can only work in radians. They never give you degrees in the AP Calc exam. So any angles you work with are always in radians. So this calculator has to be set to radians. And I'll show you, for example, let's set it to degrees just so you could see the difference here. So if I did sine of 30, right? So I click sine and then I type 30 and press enter, it's going to give me 1/2 because that's sine of 30. But if my calculator was set to radians instead, and I did sine of 30, it's going to calculate it as that. Okay. And that's totally different because 30 degrees is not the same as 30 radians. So it does make a huge difference when working with the trig functions. The angles do have to be set to radians. 30 radians is actually a huge angle because 2 pi radians is a full revolution. That's about 6 point something. So 6 point something radians is a full revolution. So 30 radians is like a huge angle. So be very careful there. But yes, it has to be in radians. Okay. And also I think in BC, it gets a little tricky because they go into polar coordinates. So if you see here, they have like option to do like polar. There's also something called parametric, but we don't go into that in AB either. Only in BC do they talk about parametric and polar. So when we're doing functions, just basic functions, okay? So basically just make sure everything is on the left. Like all of these options are selected on the left. That's the most important thing. And it's also really cool. You could do complex numbers too, but we don't do that in calculus. And to quit this menu, of course, you have the quit button. So you have to click second quit, and it takes you back to the main screen. So that's like the basic stuff. Now the math button here is very, very useful because this has a lot of operations that you need to know how to do. So if you click math, these are all the operations you can do. These two are really cool because you can convert between fractions to decimals. So basically, like how you can use this, I'll show you. So if you do like, I don't know, 2.735, I'm just making that up. And I want to turn this decimal into a fraction, which is not necessary. Honestly, this is not necessary for the exam because they only want answers in decimals. But just to show you anyways, you can convert this to a fraction by clicking this button. So it's going to turn this number into a fraction, and it turns it into a fraction, which is really cool. And you could go in reverse too. You could turn a fraction into a decimal. I'm not sure. I'm not 100% sure about that. Go to the AP, look up AP calculator rules, and it should have all those rules there. I don't have a list of all the calculators you are allowed to bring, but you can. So for example, if you have one of these, which you need to charge it beforehand, make sure it's charged the night before. And if you have one like these with batteries, bring an extra pair of batteries just in case. But I think you can bring 2 calculators just as a backup, but again, they're really expensive. So, but good question. Okay, the one that you guys are probably most waiting for. How in the world do we do derivatives and integrals on a calculator? Now, the thing is, the calculator will not like give you the derivative as a function. That's the thing that the calculator doesn't do. The calculator is not going to find a derivative for you. Like if you say like y equals x squared minus 5x plus 3, and you just want to find the derivative of that, it will not do that. But what it can do is find the slope of the tangent line at a point. So you can find the derivative at one point in particular. That you can do, but it's not actually going to find the function for you. Okay. So what's important to pay attention to here is that, let's say, for example, so there's this button here, n derivative. Okay, so when you press this, this is in the math button here. This opens like the option for like all the operations you can do, and you do n derivative. Okay, again, this is with a newer calculator, which shows it like this. If you have an older calculator, I think I'm going to show that to you guys in class because it's a little different. With an older calculator, the way you have to type it, it's a different layout and it's a little bit more confusing. But the newer calculators make it a whole lot easier. Okay, so here's the deal. This button here is the variable button. Okay, so remember when we went to mode and we had like, what was it? Function, parametric, polar, and sequential. That's why there are four options here, because it depends on like these. If you're going to be doing polar coordinates, you talk about the angle, right? But that's a complicated concept. So when you press this button, you're really just working with X. What happened here? Oh, that was a glitch. So this is the variable button. So you basically have to set this up like a regular derivative. So you could say dx, so you have to press the x. So that means you're going to get the derivative with respect to x. And now you have to write a function of x. So let's say we wanted to find the derivative of 5x squared minus 3x plus 5. So 5x squared. So you can either do raised to the 2, or you can press this button too. This is also to square. It's the same thing. You can either do raised to the 2, or the delete is like the backspace button, right? Or you can do squared like that. It's the same thing. So 5x squared minus 3x, let's say plus 2. So I want to find the derivative of this function, but you have to specify what value of x. So let's say I want to find the derivative of this at x equal to 2. So all you have to do is press equal or enter, and it's 17. There it is. You had to do no math at all to figure that out. It did it for you. Again, it will not find the derivative function for you. That you would have to do by hand, but you don't have to. And that's the cool thing with the calculator feature, is you don't, they don't want you to find derivatives because you can do it by hand, and they don't want you to find a derivative because you can use a calculator to do it. So this is a really cool feature. Sure. Let's see, what could I do? Okay, hold on one second. I'm gonna open up like a blank page here so I can like write. Okay, hold on. So like I can actually write on it. So let's say I wanted to find, so let me choose a color. Okay, find. So if I give you, why is it not? Okay, do that. See if you can do that on the calculator. So again, I'll help you set it up. So you click math, because that's going to open the menu for like all the operations you can do. And then you just scroll down to deriv. And when you press enter, it's going to set up the menu for deriv. Now, again, if you have an older calculator, let me know and I'll show you. I'll try to show you how you can do it because it's a different layout. So you press the variable because you have to say, I'm going to differentiate with respect to X. And then you type out the function. Again, this is the variable button here. So this is how you type variables. Yes. Oh, so you do have an older one. What happened? Oh, so yours gets set up like that. Wait, what happened, Sydney? Did yours show like this when you press the derivative button? So when you went, let me see. Again, you could always clear the screen. So math, go down to deriv, and then press enter. Does your screen show up like this when you press the derivative button? Oh, how does it show up? Because yours might be an older calculator. So the setup is a little different. And I think I'll show you how to do that on the, I'll show you in class on Tuesday, if that's the case. So it shows up like nderiv when you press it and so basically, because I don't know why it's not letting me show the older version. So the screen shows like this with like an open parentheses. Okay. So the way that you do that is a different story, okay? Because that's what the older calculators, the newer ones, they programmed it to be able to do cool stuff like this, like what's currently on this screen. So the way you have to do this is you type the function first. So you're going to do 3x raised to the 4, because again, this is how the calculator does it on the older ones. Then you do minus 2x raised to the 3 plus 9x. Okay, so you type that out. Okay, then here's what you have to do. Then you have to press the comma button, which if you notice here, look at my mouse, there's a comma button right here. Right? So you have to press comma. No, don't do that yet. You can't do that yet. You have to press comma. Then you press X, because now this is saying it's going to find the derivative with respect to X. Then you press comma again, and then you type -5. And then you close the parentheses. And then you press equal. Now remember, to do -5, you have to press the negative button, not the subtraction button. Okay. So if you type it like that on the older calculator, that's how it will do the derivative. So you always have to type the function, comma, with respect to X, comma, at X equal -5. That's how it reads. And then you press equal and it'll give you the answer. So as you see, the layout is a little different with the older calculators. They're all gone. They were already taken. But it's not that hard. You just have to remember that pattern. And it's the same for integrals. You just have to type the function, comma, X, and then I'll show you guys how to do integrals momentarily. What? What's your question? Oh, I mentioned it earlier. So the exponent button is, hold on, is this button here. It's above the division. It's easy to miss. A lot of people, there's so many buttons. It's easy to miss them. Oh, okay. So anyways, so to answer this question, we would do 3x raised to the 4. Oh, I'm sorry, I forgot to put x. Oops. I have to differentiate with respect to x, then I do 3x raised to the 4. That's not what happened here. Then minus 2x cubed. And then plus, oh wait. Plus 9x. Now, again, you may have to move your arrow around to help you like navigate. Actually, that brings up something I do want to mention real quick. And then we're going to stay at -5. Now, again, you don't press the subtraction, you press the minus to make something negative. So you click -5. And then when you press enter, that's the answer you should get. Which is weird. Why would that be a decimal answer? That's weird. I don't know why that would be a decimal, but whatever. That's what the calculator says. So that's the answer. Now, what did you do? Oh, you have the old calculator as well. Oh, oops. Oh, I erased it. I shouldn't have done that. Can I undo my erasing? Yes, I can. Yeah, I'm undoing it here. There. So you have to type the function, then you have to do comma x, comma -5. Did you press the subtraction button to make the I right, the subtraction button's an operation. You have to use this button here. Hold on, where's my pencil? You have to use this button here, which I have my mouse over to make the 5 negatives. So this online calculator, you have to first download the ROM. I can show you how to do that a little bit later, but yeah, like the it's complicated. This is a TI emulator, and it's you have to like download the operation that this will use. And you could download it for free, but maybe I could make that like a link and I'll put it on the Google Classroom, like how you can have a sample TI to practice with. And I'll show you the instructions how to use it. But I'll do that later. Okay, so anyways, okay. Now actually I do want to mention one more thing here, which is there's some really interesting things you can do. So let's say you're typing out like a huge number, right? Or even a huge operation. Let's say that you have like a really, really, really big function. And in a calculator section, again, they could make the functions as complicated as they want to. Even if it's like impossible to do by hand, you can still solve it with a calculator. Okay, because the calculator will do that work for you. So let's say, like, just as an example, let's say you're typing like a huge number. So like, but let's say you meant for this to be a 4, right? Because you're trying to 9, 8, 7, 6, 5, 4, and you made a mistake and you want this to be a 4. So you start panicking because you're like, oh gosh, I can't change this because the only options you see are to clear the screen. If you clear the screen, it's going to erase everything. Well, there's a very nice feature, which is the insert feature, which is the shift button. So above the delete button. So the delete like deletes one number. So you can like delete this, but if you deleted it, it removed it. But you need to make that a 4, right? So you can always do the insert button. Okay, so what you do is you click second. First, you have to move your key over to where you want the value to be placed. So I want there to be a 4 in between the 5 and 3. I'm going to go here. So I'm going to put it over the 3. Now I'm going to do insert, second insert, and now it's set for you to insert something. And I'm going to press 4. And there we go. It inserted it. So that's very useful, like especially if you're typing out like a really long, complicated function and you made a mistake, you don't want to erase the whole thing and type it all over again. You can just move your arrow around to either delete something or insert something. And that's a very useful feature, okay, especially when you're typing out really long and complicated functions or numbers. Okay, it's a little feature there. Okay, something I forgot to mention. Now, another thing too, let's say that you wanted to type the function this. Let's say you want to type that function in your calculator. How, so like as a derivative, let's say I want to find, yeah, and you know what I'm going to do? I'm going to do something else here. Actually, I'm going to do this just to show you. So let's say that this is the position of a particle at any time for t greater than 0, moving along the x-axis. And the goal is, and the question here is, what is the particle's velocity at t equal 2 seconds? Now, this is a calculator section. Are you really going to waste your time doing quotient rule to solve this? No. Why would you waste your time? You have a calculator, so you don't actually have to find the derivative of this because, I mean, yeah, if this was a non-calculator section, yes, you would have to do quotient rule because that's how you would solve this. But you have a calculator. So how do we find the velocity? Well, first of all, we know the velocity is the derivative of the position, or is the rate of change of the position. So they're asking us, what is x prime? I'm sorry, at x equal to 2. Right? That's what this question is essentially asking us to do. Now you might be wondering like, oh, but there's no t option. Like, how do I do the variable? Who cares what the variable is? Instead of t, just make it x. That's it. They might give you, like, that's going to be something too, and remember how I was talking about how you could integrate with respect to the y-axis? Just treat the y-axis like if it was x. Like, the only variable you have to work with is x. So even if they give you another variable, don't let that trip you up. Just make the variable x. It's the same math at the end of the day. So I have to mention something here though. Okay. So let's go to math. I'm going to go to the derivative. Okay. So first you have to say, well, again, I have the newer calculator. If you have the older one, you have to type out the function. Now, here's the deal though. Let me check something here. Yeah, it even does it here. Okay. This is the same thing here. Is this right? Answer me this. Again, instead of t, I'm using x. Is the same math. Right. Very good. And you know what? If this was multiple choice, they would make this the answer. They would give this like an answer choice and it would be wrong because they're checking to see if you typed the function incorrectly. This is incorrectly typed because the way the calculator is reading this is like this. It's reading it like 3x plus 4 divided by 6x squared, which is obviously a completely different function. So you have to be incredibly careful in the way you type these things in. So you do need parentheses on both. Okay. Now, going back to the insert feature, instead of having to erase the whole thing, let me just go to where I want parentheses. So I'm going to go second, insert an open parentheses. Second, insert a close parentheses. Second, insert an open parentheses. And second, insert an open parentheses. A close parentheses. And there we go. Yeah, it's a little annoying because there's a lot of parentheses and that can be a little confusing at first. The newer calculators that actually have like a colored screen, they actually like do the parentheses in different colors so you don't get confused. But with these, you just kind of have to like keep track of your parentheses. So we're going to do the derivative of that at x equal 2. We're at t equal 2. Instead of t, we're doing x. So what? It's the same math. And there's our answer. And then you would select that answer choice. That would be the answer choice to select as the multiple choice. So be very, very, very careful with the way you type out a function. And remember, if you open a parentheses, you have to close it. Okay, the calculator will give you an error if you don't close the parentheses. Is this making sense? Do you need me to try another one or do you think you guys are okay? Did you guys get the same answer? Now try to do it on your own. Tell me if you got the same answer. Okay. And just a little side note, and I've mentioned this before, and this is very important. On a free response, you have to put at least 3 decimal places. You can do more, but you have to have at least 3. Yes, but let me just show you integrals first. Okay. So integrals is the same operation. So again, you could always just clear the screen. When you press clear, it just clears the screen. But it saves the previous answer as well. Like anything that it calculated is always going to save that answer. So you could always like transfer to the next problem. Now, if you want to do an integral, okay, keep in mind I have a newer calculator, but look at how cool this is. Let me clear the screen. Let's say I wanted to find, oh, here's Alani. Hi.
Hi.
Hi. Okay, we've been going over some things, but I've recorded, so you can always go back and watch what you missed.
Okay, thank you.
You're welcome. Okay, now with the sigfig, no, it just means like you always type the number, but if there's a decimal, you have to type the 3 digits after. If there are, like if the answer is like 27.3, you don't have to say 00. Like you don't have to do that. But it's only if the the decimals continue forever, like you have like more than 3 decimals, you just have to put the first 3. You could put all of them. That's not wrong. It's just when they're grading it, they're just making sure that the first numbers up to the 3rd decimal place are correct. Okay. So if the numbers, if that's the answer, that's the answer. You just leave it as 27.3. But if the answer was like, you know, you could type this whole number out correctly and you'll get all the points. But you can just put the first 3 digits. And the thing is, you can either truncate or round. They will accept either answer. So like in this case, if you give 27.372 as the answer, that's correct. If you give, that's also correct. They would accept both answers. Because they're just checking to make sure that the first 3 digits after the decimal place are correct. Does that answer your question? Okay. Now, just like with derivatives, the calculator does not find functions, but it can find, so like with derivatives, as I said before, finding the derivative, it can't do, but it could find the tangent, the slope of the tangent line. It can find that. It can find a slope of the tangent line. Same thing here. It cannot find an antiderivative. The calculator cannot find an antiderivative, but you know what it can find? The area under a curve. Okay. Because again, the calculator only calculates values. It doesn't calculate functions. Okay. So that's why a calculator cannot do an indefinite integral. It can only do a definite integral. So if we press this, okay, again, this is the newer version. Let me just show you, and then I'll show you how to do it on the older versions. But it's kind of the same thing as with the derivative. So like, for example, let's say I want to find the antiderivative from 2 to 7 of 5x squared minus 3x plus 2. Right. So I'm going to say first I set the limits of integration. So I say from 2 to 7, and I go up to 7. And then I go to the parentheses and I type out the function 5x squared minus 3x plus 2. And then you have to say with respect to x. Again, when you differentiate or integrate, you have to say what variable do you want to get the derivative or antiderivative with respect to. So with respect to x. And then you press enter, and there's the answer. No math needed. Literally did it for you. Now, if you had the older version, it's a little different. The way you would do it is it would show like, how would it show? Let me see. It will do fn because it's saying definite integral. So the fn int with the parentheses. So you set it up the same way. You first type out the function. So you'd say 5x raised to the 2 minus 3x plus 2. Then you have to put comma with respect to x, comma, and now you type out the limits of integration. So you say 2 comma 7 close parentheses. So this is saying integrate this function with respect to x from 2 to 7. That's how that reads. And then you press enter and you should get the same answer. Try it yourself and let me know if you got the same answer. So try it yourself first. You got it? See, isn't that cool? So that's why, again, like on the calculator section, they're going to be testing one, that you know how to type something into a calculator. So they might give simple things like this, but they'll make it like a really complicated function. So one that you can't actually do by hand, like one that's like really, really hard to do without the calculator. And they're going to test that you know how to correctly integrate the function or correctly find the antiderivative. Um, and then, um, or they test that you know how to apply the concept. So it doesn't matter how complicated the function is, you know, there might be like a PVA problem. So the calculator section is like a lot of PVA, a lot of application problems to make sure that you understand what the derivative and antiderivative mean in like context of a problem. Okay, well, I'll have you guys do one on your own. I challenge you guys to do this. So hold on, I'm typing the function here. Okay, see if you can figure that out. And let me just clarify, if you're wondering where's the E, you can either, it's either here, where's my pen? It's either this button here, again, you have to click the second, but if you do that, then you have to press raise to, or you can press this button, which immediately turns it into like E raised to a number. Remember, I'm giving you the rate and I want the net change. So this is net change theorem. Now again, don't get hung up by the variable t, just make that an x. It's the same function. No, you don't. You can, but you don't have to. Yeah, I'm doing it now. See, sometimes you might see it's taking a while because it's calculating it. But yeah, the answer should be 1.440. But notice it says e to the 10. They're not going to give you answers like this, but they're not going to give you answers like this, but you know what that means, right? E to the 10. That means 1.440 times 10 to the 10. But you don't need to know scientific notation here. So this answer is because obviously I made this function up, but you will never get answers like that big. This is actually a huge number, but you'll never get a number like that. So don't worry about that. But yeah, those, if you got this value, then you did it correctly. Okay, so it doesn't matter how complicated the function is, the calculator will be able to figure it out. Okay, and remember, if they're giving you another variable other than x, just make the variable x. It's the same function. It doesn't make a difference. Okay, so I guess we could work through some problems here. Let me clear. Let's see. This is not for you guys. This is just for us to do in class. So this is not available to you guys. Okay. Why don't you guys give this a try? Morgan, you could always use derivativecalculator.com if you need to, like for the time being, so you can try to find the answer. Now remember, notice we're working with angles, so you need, when you see a trig function, you have to make sure that the calculator is set to radians, because one of these answers, they calculated it um by using degrees, which the answer would have been correct if we were talking in degrees, but calculus is always done in radians. So just type your answer in the chat, what you got as the answer, and let's see if you got it correctly. Just type the letter, like A, B, C, or D. Oh, this one's a little different because actually, because this one you actually have to do a little math on your own. This one's a little different. Oh yeah, this one's interesting. Yeah, this one's not like what we did, but you should still be able to do this. Oh, this brings up something very interesting that I need to show you guys as well. So if you're stuck with this, so again, they're asking what is the velocity when its acceleration is 0? So to find out the time, you have to find it, plug into the velocity. You have to find the time when its acceleration is 0. So you kind of do have to do this by hand. You're going to have to find the first derivative for the velocity and then the derivative again for the acceleration. Now you have to set that equals 0 and solve for t. Now notice you're going to have to use an arc-trig function to figure this out. So to show you where to find the arc-trig functions, let me just be clear here. So take a look at the calculator. You don't do like cosine, 1/4 raised to the -1. Or you could see this button here called raised to the -1. Oops. Okay, hold on. Because what that's going to do, this button is actually called the reciprocal button. Okay. When you raise something to the -1, you're essentially finding its reciprocal. Arc cosine is not the reciprocal. This would actually give you what I just typed here on the calculator would actually give us secant of 1/4, which is wrong. Okay, because I'm not looking for secant, I'm looking for arc cosine. So the arc-trig functions are up here. They're the shift buttons, they're the second buttons. So you're going to have to do arc cosine of 1/4. That's arc cosine. Okay. So that's the value of t. Now, this is actually really interesting because this takes on, so you could write this whole number out. So as we calculated, the time when the acceleration is 0 is 1.318116072, right? But here's the cool thing. I'm not going to waste my time typing that number again. You know why? Because the calculator is saving that answer. So what I can do now, I'm going to clear my screen. I'm going to do math, derivative. I'm going to type out the function, right? So I'm going to say -4 sine cosine t minus, I'm gonna have to put that in parentheses. Actually, I don't need parentheses here. X squared divided by 2 plus 10. But watch this. I'm just gonna say second answer. Why would I waste my time typing out that answer when it's already saved as an answer? So I'm going to say at that value of x. Then I press enter and I get 2.554, which is D. And is that the answer? Let's see. Yep, that's the answer. It is D. This one was an interesting one, but you see how you kind of needed to use everything. This here again, as I'm saying here, you really didn't have to do much math in this problem, but you did need to know how to use the calculator. But see how cool that feature is? See how interesting? That why would I type this whole number out when it's already saved as an answer? You could have done that too. You should get the same answer. It's just, I mean, yeah, you could do that. And you could type, so yeah, you could have done that too. Darn it, I erased that answer. Hold on, let's do it. So arc cosine of 1/4. So you could do 4 sine of the answer, right? Minus the answer. That would have worked too. You get the exact same answer. You see, that's why I love the answer button. A lot of people like ignore it, but it's really useful because especially when you get like really ugly numbers like that, so you don't have to waste your time typing out this number all over again. And the reason you shouldn't round, you should know this from chemistry, never round an answer until the end. So you need to save all the decimals and you round your final answer. You don't round early on, because if you round early on, your answers are going to get really, really bad. Like they're going to get really inaccurate as you keep plugging in numbers. So this one was an intense one, but it's not, again, if you understand what's being asked, it's not hard, and you do have a calculator, so it will find all of that for you. Okay, so that's a very interesting one. Okay, let's take a look at another one. Oh, shoot, sorry, you weren't supposed to see the answer. Hide. Why isn't it hiding? There. Yeah, so this here, well, I'm not planning to finish this today. Like I'm planning to get through a few problems today. And we'll spend more of class time working on these problems. But this is for the problems I have here, these 19 questions I have here now. That's just for us to do in class. I gave you another progress check that has a bunch of calculator problems. And I'm making it due Friday. We agreed to do the test on Tuesday, right? The following Tuesday? Okay. So yeah, I made the homework, so you can ask questions like Tuesday and Thursday if you need to. But there's a few I've already skipped. I haven't gone over. I'm not done with the calculator yet. I've showed you pretty much everything you need to know how to do on like the main part of the calculator. But wait till we get to the actual graphing part. That's where it starts getting fun. But because there's some really cool stuff you can do on it. But why don't you guys try this one on your own? Oh, wait, actually, sorry, you can't do this yet because I need to teach you the graphing section. So let's you know what, let's take a quick break and then that's fine. I'm still recording this. So you could continue watching it on your own. But thank you for coming. I'll see you later. Bye. Okay. Well, let's take a quick break. And then we will resume. So I'm gonna go get some water. Okay, are you all still here? I know it's a Saturday, but we gotta carry on. We're almost done. I mean, I just have to now show you guys like how to graph stuff. And there's some really cool things you can do on the graphing section. So, oh my God, why is, give me a second. I need to get a different charger. Hold on. Let me share my screen. Okay, so a few things here to pay attention to. So let's go back to the calculator. Okay, so now let's pay attention to these buttons up here because these are really, really cool. Okay, so the first one is the function button, which is the y equals button. If you press this, it's going to show you a bunch of functions, and you can have a bunch of functions existing together, right? So let me just show you how this would work. So let's say, for example, I wanted to graph the function x squared minus 3x plus 1. Okay. So what this is doing now is this is saving this function as the first function, as y1, right? This is our first function. Now, if you press the graph button, it's going to graph it. So now you might think like this is a little too hard to see. So this is where the window button is useful because you can adjust the window settings. So if you click window, this will allow you to change like the window that you want. So you could set like between what values of x. This is very useful. Like for example, if you're talking about a function and they say between the intervals 5 and 7, you can have it only graph from like 5 to 7, right? So like that way you only observe the function in that interval between those values of x. Or you can go from 0 to 10, right? But you know what, let's do like minus 2 to 10. Now, x scalar, that just means how much, like, what do you want? How do I explain it? Like each tick, like each, how do I explain? Like if you want each tick to represent 1 unit or 2 units or 3 units. So like if I press 1, look at what happens here. This is graphing from minus 2 to 10, but each tick represents 1 unit. So that's like minus 2, minus 1, 0, 1, 2, 3, 4, all the way to 10, right? But if I want to make it in terms of 2 instead, I could make that 2, and there's going to be less tick marks. And notice that represents, you know, every tick mark represents 2 units. So 2, 4, 6, 8, 10. So that's what the scalar for is for. So that's like if you're working in like hundreds, like if the interval is like 0 to 100, you might want to make the scalar 10, right? So that each tick represents 10 units. So it just depends on how big the graph is going to be. And the same thing with the y values. You can change between what values of x you want the y values. So the y minimum, let's say, is -5. Let's say the y maximum is 5, and I'm going to do that by 1. So you see, it adjusts this graph or the picture to be in this interval, like from -5 to 5 here and from -2 to 10. Well, let's make the x values a little. Let's go from -2 to 5. Right? Because you might want to adjust that to get a better view, right, of what's going on. Another thing you could do too, this is another really cool thing. You can also, if you go to window and you keep going down. Oh no, I'm sorry, that's not what I meant to say. Again, if you ever want to leave something, you have to quit. So you have to press second quit. What I meant to say was you can always press zoom. And zoom kind of does it for you automatically. Like this is useful if you want to adjust the intervals between very specific values, right? But if all you want to do is zoom in, there's different options here, but the best one, in my opinion, is zoom square. So what that means is it lets you create a square or a rectangle where you want the zoom to be placed. So you could press zoom square. So it's going to graph the function. And now so I'm going to move. Notice there's going to be an arrow as you move around. So first you press which corner you want the square to start in. So let's say I want it to start here. You press enter. And now when you move, wait, what's happening? Wait, what? Oh, I'm sorry. I'm sorry. I was talking the wrong thing. I meant to say zoom box. My bad. Zoom box is the one that lets you create a box to zoom in. My apologies. Zoom box. So you move this around, setting where you want one of the corners of the box to be. You press enter. And now when you move the other arrow around, it creates a box so that you can zoom in what you want it to zoom into. You press enter, and it like automatically adjusts the window for you. So you zoom in on what you want it to zoom in on. So that's a pretty cool feature there. Okay. Now, why is graphing so useful? Well, let me show you. If you click the calculate button, okay, you ready for this? This is really cool. First, you have to click second, right? Like shift, second, calculate. And these are all the things you can calculate on a graph. You can calculate the derivative, you can calculate the area, you can calculate the points of intersections, you can calculate the zeros, you can calculate the max and min, you can calculate any value that you want. So for example, if I want to calculate the value at x equal 1, it'll show that, and I press 1, press enter, that's the value of y at x equal -1. If I want to find the zeros, which remember are your x-intercepts. So, okay, so this is so cool. This is so cool. Hold on. Let's say I want to find the zero. So this is how these work. These are very interesting. The zero. That means there's the x-intercept. So obviously there's two x-intercepts here. So you have to specify which x-intercept you want to find, right? So you have to select a left bound and a right bound so that it knows between what values of x to find the zero in between. So for example, let's say I wanted to find this zero. Let me go here and draw, hold on. Let's say I wanted to find this zero, the one on the right, right? So the way I would have to do that is I'm gonna have to move my arrow to create a left bound. So I'm gonna just press some point to the left of the zero. I'm gonna move the arrow to the right, and I'm gonna pick any point to the right, just any point. And then it's gonna ask you to like guess, find where do you want the zero to be? So like around there, you press enter, and there it is. At x equal 2.618, that is the x-intercept right there. Okay, and if you want to find the other one, say calculate the other zero, you go, I want to find the other one, so I pick a point to the left, any point, because it creates like a bound, right, where it's going to look for the zero. I pick any point to the right, and then I take a guess. And that's my other zero. No math needed. No factoring needed, no nothing. It did it for you. So that's really cool feature there. Now, if you wanted to find the minimum, right? Let's say I want to find the minimum, right? That's useful because they always ask like, what's the relative max? What's the relative minimum? You press minimum and it's the same thing. You can have multiple minimums, so you have to specify which minimum do you want it to find. Obviously, this just has one. So you pick any point to the left of the minimum, any point to the right of the minimum, and then guess where the minimum is. And there's the relative minimum. How cool is that? You did not have to find derivatives and set it equals 0 to find the critical points. It did all the work for you. How cool is that? Now, if you want to find the derivative, you can also do the derivative on this. So instead of doing the math button, you can also do the derivative on the graph. So let's say I wanted to calculate the derivative. You have to specify what value of x. So it's going to show here and it's going to let you like move the cursor around, but you can just type at what value of x you want. So let's say I want to find the derivative of x equal 3. All I have to do is type 3. It's going to show x equal 3, press enter, and there's a derivative of x equal 3. And it's 3 coincidentally, I think. Let's see. Let's do like 1. Let's calculate the derivative at 1. The derivative at 1 is -1. So there we go. And look, oh my God, look how cool this is. Look how cool this is. The integral, you have to specify between what values of x. So again, you can either move your cursor around or you can type the values of x. Let's say I want to find the interval from 1 to 4. I'm going to first type 1, enter, 4, enter, Look how cool. 1.5. That is the area. That is the net area. It's calculating the net area. So it's a very, very interesting feature there. And this works the same for all calculators. Like it's all the same. Are you guys following? Do you have any questions? Do you want me to do another one? But actually, before I do, I want to show you one more thing because there's one more very important one. This is especially important for like areas between two functions, which is the intersection. So this is if you want to find the intersect between two functions. So watch this. I have this function. This is graphing y1, and I want to graph y2, right? So let's say I wanted to graph the function x minus 1. So now what this is going to do is it's going to graph this function and this function. So when I press graph, wait, why is it doing this? Hold on. Why did it leave the antiderivative? It shouldn't do that. Why is it doing that? Is this a glitch? I wonder if this is a glitch with the simulator because it shouldn't keep showing that area. I don't know why it's doing that. Well, that's another thing too. Like if you highlight the equal sign, so you see this one's highlighted, so it's only going to graph that one. So if you highlight this one as well, it should graph both. Okay, now it shouldn't have that problem. Okay, cool. So as you see, let me adjust the window a little bit. Let me raise the y value a little bit. Let's go to 4. Now let's say I want to find the point of intersection. Let's say I want to find this one right here. So what you do here is you click second, calculate, intersect. Now again, there's 2 point of intersections. So you first have to specify which is the first curve, which is the second curve, and you kind of start guessing, like putting around where you want the x-intercept to be, and then you guess. So around here, where the intercept is. And there's the point of intersection between the two functions. So those are like the main things to do in the graphing section. This is really useful. This is really, really useful. Like if you're asked to do like an analysis of a very complicated function, you can just type the function in the calculator, graph it, and look at it and look for the answers just from the graph. And that's a very, very useful feature. Okay. Now you may be wondering, okay, so what if I wanted to find the area between those two functions? So this is the last thing I'm going to show you. Okay, this is the last like super cool thing. Okay, and then I'll give you another example here. So the thing is, this is not, the calculate section is not going to do that. It's not going to calculate the area between the two functions. Now, I want to show you something very interesting. So obviously by looking at this, we know that the second one, the line, which by the way, another thing you could do, if you go to the left, you could change the type of line it is. So you could either make it like a solid line, you could make it, you can have it shade upwards, you can have it shade downwards, you can have it have like dots. I think that's actually the trace. You can have it do like different things. You could make it a dotted line. So you could change like the type of line it is if you want to tell the difference. So like if I make that a thick line, it'll draw the first one, and then the second one is a thick line. So that way you could tell the difference between the two. So anyways, as we see, looking at this between this interval, actually, let me do this here real quick. I'm going to make this a word problem. Find area bound by now again, you have a calculator here, so you don't actually have to find the point of intersections algebraically. You can literally just have the calculator do it for you. So first things first, you go to calculate, well, we go to graph and we go to calculate the points of intersections. So first, let me find the first point of intersection. So the first point of intersection is at 0.58578644. That's the first point of intersection. Because the whole goal here is to set up the integration, right? We're basically going to want to do this. And as we see here, the thicker function, which is the second value, the second function is the one above. So it's basically going to be, we're calling this y1 and y2. Essentially, right? That's what we want to do. We just need to find between what values of x are we going to integrate, right? So we found the first one. Oops. 644. And now we need to find the right one. And this is a legit free response problem I've seen before. Okay. Different functions, but the same exact concept. They want you to do it this way. Then we're going to calculate the other x-intercept. Or the other point of intersection. So you kind of find where the first curve intersects, you find where the second curve intersects, and then you guess where the intersection is. And we see that that's at 3.4142136. Notice how I'm writing all the digits. You do not want to round until you get to the end. Okay. So as we see here, we basically set this up. Okay. Now, let me show you. This is the last really cool feature that you can use. Okay. And I pretty much taught you everything you need to know about how to use the calculator on this exam. Okay. So let's quit to go back to the main screen. Obviously, I'm going to have to now find this integral. So one way to do this, of course, is let's go to math, integrate. Obviously, if you have the older version, you have to actually like type it out in that notation, but we have to type these. We're going to have to type those values. So 0.58578644, and then 3.4142, oops, 4142136. Okay. Now, you could type out the entire function, right? You could type out x minus 1 and then minus this function. And again, you would use parentheses, but this is the cool part. You don't have to, especially if the functions are really complicated. Obviously, these are really easy. So you could very easily just combine them and do like, x minus 1 minus x squared plus 3x minus 1. Again, notice how I have to distribute the subtraction, right? So that's a pretty easy one to do, but especially if it's like more complicated, you don't have to do this, because pay attention here. This is very, you don't have to do this. This I actually learned for the first time like 3 years ago. I used to do it the way I was just explaining. It's a much easier way, because these here are being saved. And this is very useful for free response problems, especially when you have like a beginning function that you're going to use for all the parts. It's saving that function here. So if we go back here, let's go back inside. Are you ready? Oops, let's go. Okay. You click vars. Go to the right for y variables, function, and these are all the functions that are stored in the y equals. So we can do, I'm going to press enter, y2, there's the second function, minus vars y1 with respect to x, and there's my answer. How cool is that? So this is actually a really, really, really useful tool. Again, if you have a free response problem, we're going to be using the same functions for like all the parts. So you don't have to keep writing the function over and over and over again. It just saves it. Just you type it here and it saves the function for you. And like another use for that, for example, is you could do like, if I want to find the derivative with respect to x, instead of typing out the function, I could just go to vars, y variables, functions, y1 at x equal 2, and there's the derivative at x equal 2 for function 1. So this is very useful, again, especially if you're working with a really complicated function that you don't want to have to keep typing out every single time. You can just store it here, and you can just keep using it for any operations. So that's pretty much everything you need to know, honestly. That's all the main key features. I think I'm going to update my PowerPoint slides to like just briefly explain how to access all of this. But yeah, this is pretty much all the main stuff you need to know how to do. Should we do another like problem to practice with, or do you want to do some multiple choice questions? Okay. So but do you guys feel comfortable? You see how cool, like how useful the calculator is. Like you really don't have to do math. You just have to know what you're doing. So it's very, very interesting. Okay, so let's go take a look at this one. Let's see if you could figure this out. Let me clear the screen. So here you have the velocity of some particle, and they're asking which of the following statements describes the motion of the particle at t equal to 1. So there's different ways to do this, but I'm going to see if you guys could figure it out. So list out in the chat what your answer choice would be. And I'm going to show you how I will do it once you guys put your answer choice. And I'm curious to see if anyone does it the same way that I would do it. You should be done with this one by now. This shouldn't take too much time. You're probably overthinking it. I'll give you a hint. If you know how to read the graph of a derivative, this should be pretty easy. Yes. I mean, again, you could, there's different ways to do that. I'll show you both ways that you can do this. But I think graphing might just be faster personally, but that's my personal choice. Okay. Alani, Sydney, have you guys made your choice? You can DM it to me. Again, keep in mind, I'm gonna be showing you guys how to use TIs, but if you do have a Casio, because they are cheaper, but they're a little different to use. So I do know how to use them though, so you can ask me in your personal time. But in class, I'm gonna be working with TIs. So which choice would that be, Alani? Which choice would you pick? Okay, let's see. So two ways you can do this. If you want to go the longer method, you could, is there a way to do value here? No, there isn't. Well, you could do like, okay, what's the velocity at 1? So you could do like, what's the square root of 1 minus cosine of e to the 1, right? So, and this would be the velocity at 1, which would be 1 minus cosine e, which you would say is 1 minus cosine e, which is approximately 1.9117, blah, 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 right? And then I need to know what the acceleration is at 1, because remember, to determine, if you look at the answer choices, they want velocity and acceleration. So I could go to math, find the derivative of the square root of x, square root of x, minus cosine of e to the x, at x equal to 1. So this would give me the acceleration at t equal 1, right? So I would get that a of 1 is approximately 1.616, right? So the velocity is positive, meaning to the right, and the acceleration is positive, so that means the answer should be B. Is the answer B? Yay, the answer is B. Good job. Right? So that's one way to do it. That's like the mathematical way of doing it. You could also do it graphically if you feel comfortable reading a graph. So we can go here and actually type out the function square root of x minus cosine of e to the x, right? And then you graph it. So remember, this is the graph of the velocity. So if we go to calculate value at x equal 1, this is the point at x equal 1. So as you see here at x equal 1, the velocity is above the x-axis. So that means you have a positive velocity. And that derivative is positive. You don't even have to calculate the derivative. You can see visually it's increasing. So the acceleration is positive. So you can see right there it has a positive velocity and a positive acceleration. So that's faster, right? But both ways are correct. So I don't care how you did it, but you could have done either way. And you could have also done second calculate the derivative at 1 if you really wanted to. And as you see, it's a positive derivative. So yeah. Pretty cool, right? I love the calculator. Ooh, this one's interesting. Why don't you guys give this a try? Again, there's different ways. There's no one correct way to do this. So I might actually do this slightly different than you guys, but I want to see how you guys you try to figure it out. So see if you could figure out what the answer is. Well, I'll give you a hint if you want. Do you want a hint or you want to try it on your own? Okay, when I see this, my immediate assumption when they're asking equal acceleration, hold on. Yeah, yeah, because I see equal acceleration, so I think point of intersection, right? And I showed you guys how to find point of intersection. So see if you can figure that out. That's how I would do it. Okay, but maybe you find a different way because you could also do this algebraically, but it's in my opinion, it's just easier to graph and find a point of intersection. But that's my choice, my opinion. Now remember, this is trig, so always double check. Like first thing you have to do before you start the test is make sure your calculator is set to radians, because if it's not, the answer will be completely wrong. Yes. Because we're trying to find when the acceleration is equal, not when the velocity is equal. By the way, don't send the chats um to co-host because that's on my iPad and I can't see them when I'm writing on the iPad. So just send them to the host chat. Okay, I don't know what the answer is, so we'll do it together. But let's see if you got the right one. I'm still waiting for other responses. What could people possibly be doing on a Saturday afternoon? I mean, I guess they're with their family or whatever. I mean, I'm glad you guys are here, but it's sad that there's but this is helpful though. Like you can't tell me this isn't helpful. but I get it. I would rather be like sleeping. Okay, so what I would do is, okay, I'm gonna have to do a little math here. So I'm gonna do v prime, v1 prime, right? The first one would be negative 6t plus 8. So that's the acceleration of the first particle. Then the acceleration of the second particle would be cosine t, right? So now what I'm going to do is I'm going to go to the calculator and I'm going to write both of these because these are now the accelerations. So again, not the subtraction, minus 6, negative 6, not minus, negative 6x plus 8 and cosine x. Okay, and I'm going to graph these. As you see, there is a point of intersection. So you can click second, calculate, intersect. So you kind of go where the first curve is intersecting, where the second curve is intersecting, and then like make a guess. And there we go at 1.286, which is A. Is that the answer choice? Yes. Did you adjust the window? You can always go, like I said before, you can always go to zoom, or you can just go to window and adjust like the window settings. My safe bet is to always do like minus 10 to 10. Like I always do that just so I have like a point, right? Like minus 10 to 10. That way it gives me an idea of like where everything is. And then you could zoom in and zoom out as appropriate, as needed. So like see here, when I zoomed out, I saw that. So now I can zoom. And I like to do zoom box. So I can set up a box where I want it to zoom. Okay, hold on. Wait, let me help Sydney here. Go to the window. How are you? Because remember, you have x min and x max. You have to put the left value of x first and then the right value of x. And same with the y. You have to put the lower value of y first and then the upper value of y. Did you use the negative, the subtraction to represent the negative again? You typed it just like this. Did you type it exactly like this? And in the window, you did minus, again, the negative, not the subtraction. Negative 10 to 10. And make sure the scalar is set to 1. Then let's do negative 10 to 10. And then when you graph, you should get that. Well, you can either like turn on your camera and you could show me, or you could send me a picture on Remind. Oh, you see, that's what I was telling you. You have to pay attention. X min, X max. X min is the left, X max is the max. If you flip that, it's going to confuse it. Did you get this graph now? Okay, so I'm going to zoom. Yeah, exactly. So let me zoom so we can see. Yeah, I should probably make like a nice PowerPoint slide to like explain all of this. Because the one I have now is like not that great. Yeah, you have to press both lines. Again, you just have to follow the instructions. So when you click second calculate, intersect, you move the line around the first, you move the point around the first function, and you kind of go to where the point of intersection is. You move the point around the second one to find the point of intersection, guess, and then it'll tell you the answer. Yay. And again, if you did this in degrees, you would have gotten a completely different answer. So again, I can't stress enough how much you have to pay attention to radians. Okay. This one's interesting. Let's see if you can figure this one out. Oh, darn. You didn't see that. Okay. So here's a function. See if you can figure it out. And again, this is a calculator section problem. So now it's very interesting because in the calculator section, multiple choice, not all of the problems need a calculator, but majority do. But they do put a lot of like theorem ones, which actually do not need a calculator. So, but yeah, there are for sure going to be questions where you will need it. And I think it might be a good idea to use a calculator for this one. Oh, we're almost done. We're good. We're gonna wrap up. I think, let me see, what is 5? We'll do 5. We'll end here. And I think now that we have a basics, and hopefully people watch this video by next class, so I don't have to waste my time going over the calculator again in class. We can do more. My goal is to get through all 19 questions this week. Okay. And the problems in the progress check for you guys are similar to these. But let's just finish this one. But yes, I should maybe in the next Zoom call when we do, my plan is to do another Zoom next Saturday and then in person the last 2 Saturdays, if possible. I need to talk to Dr. Rodriguez, but I'll play music next time. Did you guys figure it out? Tell me which answer you got. And notice it's saying from -4 to 2, so you can set the window already to -4 to 2. I'm gonna go ahead and solve it, or do you want to spend a little bit more time figuring it out? No, because again, the calculator doesn't calculate antiderivatives. And you don't have to do that. You don't have to do what you're saying. Because if you know how to read the graph of a derivative, you can figure this out. So you set the function, you type it out. Okay. Again, the calculator will not find derivatives, nor will it find antiderivatives. It can only find slopes of tangent lines or areas in their curves. That's all it can do. Okay. So we're going to type and finding the antiderivative of this would be a nightmare. So I wouldn't even do that because that's really, really complicated. So we can go then to, I'm going to set the window, and I know the intervals from -4 to 2. So I'm going to change this from -4 to 2. And I don't know, let's say from -5 to 5. I'm going to graph it. Ah, very interesting. So I can see here, again, this is the graph of the derivative, not of the function. So remember, the x-intercepts here are the values of x where the derivative is equal to 0. So relative extremas occur when you change, they're either max or mins. So this is not, because there the sign doesn't change. It goes from negative slope to negative slope. So that would be more like something like this, from negative slope to negative slope. That's not a relative extrema. The only relative extremas would be here, 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 and here. So there would be 4. This first one would be a minimum because it goes from negative to positive. The second one would be a max because you go from positive to negative. The third one would be a min. The last one would be a max. So you have a total of 4 relative extremas. Let's see if that's the answer. Wait, what? 6? What? What? I'm confused. Wait, hold on, unless this did intersect. Hold on, hold on. Let me zoom in. Did this actually intersect? Because it may be too far to tell. Let me zoom into here. It did intersect. Oh my God. So it did have 2 others. Yep. So it did have 6. It did intersect there. It didn't bounce off. From a distance, it looked like it bounced off, so I wouldn't have considered that an extrema, but it did actually cross. So maybe that's a lesson learned. If you're unsure, zoom in and confirm. So you could see where my mistake came in. So let's zoom out again. Yeah, that's really hard to tell. That's really hard to tell. So yeah, you have to be careful. I'm very curious to see what the results for this question were when they were actually given for real. So my bad. Yes, the answer was 6 because there indeed were 6 points of intersections. Where there were 6 zeros. 6 points were across the x-axis. Do you guys see that? Does that make sense? Do you guys follow? Any questions? Okay. Well, if there's no other questions, I hope that this was useful at least. Like, do you guys feel like you learned how to use the calculator?
It's nice to know the basics. I have to like go back like after this and practice some more.
Yeah,
But
and I'm gonna upload the video as soon as it's finished uploading. So you can watch what you missed.
okay, thank you.
You're welcome. Okay, well, thank you guys for attending. I'll upload the video so you can rewatch this again if you want. And what I plan to do on Tuesday is just continue from 5 and on. Okay, and we do more practice problems, but you should already have the progress check available for you guys. So just start working on that. And if you have any questions, you can ask during class or tutoring. Okay. So I hope you guys enjoy the rest of your weekend. I'll talk to you guys later. Bye.
Bye. So.
Bye.